Hello, everyone. Thanks for joining. It's Tuesday, and that means very often it's CharIN Tuesday. So we often get the question, how can I certify my product? Certify that it's safe and that it's compliant to ISO 15118. So we have a couple of experts who will be answering all your questions and probably much more than that. We have Woo Yoon from the Korean Electrotechnical Research Institute, Gary. We have Jan Grossman from Vector, and Vector is a manufacturer of testing equipment. And then we also have Albi Kospiri from the testing house TUV Sud. And here it's really hands-on how to test EVs, how to test chargers. So we'll be talking about interoperability, about conformance testing, and why it's so important. And hopefully it will give you also an idea of the progress that has been made to come to a worldwide CharIN certification process. But besides this certification process, CharIN also organizes festivals every year, 3 in total, 1 in Asia, 1 in Europe, and 1 in the United States. The next event will take place at the Comemso facilities in Germany from April 20 to 21. Then in September, at the CARI facilities in Korea from September 7 to September 9. And then finally, we go to California for the Sunshine from November 16 to 17 at Lucid Motors. So I hope that this seminar will be very interesting to you. Any questions are welcome. Don't be shy. And in the meantime, I introduce you to Klaas Bracklow, who is the chairman of CharIN. Klaas, welcome.
Yeah, thanks for the nice introduction, Jacques, and thanks for making this CharIN Tuesday Asia possible. So I love that. A good Tuesday is a CharIN Tuesday, and interoperability and conformance and certification is one of our subjects driving us for a couple of years. And so I'm happy that we are close to going public. So we plan that with the first pilots end of April, which is in almost 6 weeks from today. And thanks to the contributors, because that is a part of hard work to define the processes and the test steps, and that thanks goes directly to our 3 discussion panelists of today. And yeah, I'm happy to listen to see your view on certification process and how that brings more quality to the global charging network. Just to mention that we are around 45,000 CCS chargers worldwide, and that is continuously growing. Just yesterday, Volkswagen Group announced to having additional 18,000 chargers in addition in Europe. And you can see that steep and fast growing with more market participants. And at that stage, we are hopefully good in time. And so I give the stage to our brilliant panelists. Thanks so far.
Thank you very much, Klaas. I'm trying to switch on my camera. Here I am. All right. So very soon we will be starting with our presentation with Woo Yoon from CARI. But before we start, I want to tell you that there will be a polling question after each speaker. And there will also be a polling question. Actually, so there should be a polling question now. I'm not sure if that will be coming up just before Woo Yoon starts. Yes, here we are. So the question is it important for your company to receive an official certificate that states that your product or service passed the conformance testing? You can choose between yes, no, or not sure. And that will be the beginning of the basis of our discussions later on. And then we will have Woo Yoon, who is from CARI, and he's really the father of the the conformance testing process and strategy. So he's really the right person to talk to. But before that, I just want to check, do we have an answer to the questions? Oh, very good. So almost everybody needs to have a system needs a system in place to certify their products. So Woo Yun, so
yeah,
now the floor is yours. Thank you.
thank you very much for introduction, and I'm very honored to have me as the panelist. This let me guess, and after this presentation, we will. This is my hope that we will have this another polling about the question. Just a joke. Yeah, today I'm going to give some presentation. That is a 15-minute presentation, so I would like to give the short impression, and then my objective is that you're gonna get some interesting about the conformance testing for interoperability. Please go on the next page. Yeah, before giving the presentation, I would like to address very short the Korean government plan that is a very powerful and very strong and promotion on the Korean EV market. You can take a look on the first table. That is by 2020 in the Korea, we have this 135,000 EV having registered, and then EVSE is 64,000 have been installed, including the AC and DC chargers. But according to the Korean government plan, this is 2025, this 1.13 billion, the EVs will be under driving or the operating in the road, and then more than 500,000 EVSEs will be installed. How? The Korean government gave the very strong plan and the strategy as a duty and then a regulation for the building. So new construction building that have to install at least 5% of the parking spaces with the chargers from the 2022, and then already the constructed building, the number of the chargers should be installed with the 2 point of the charge parking spaces from the 2023. So basic categories of that building is apartment, mart, and department store, and then public parking lot and the public government building, something like that. As a reference, the number of the parking spaces in the apartment in the Korea, I guess 40 million. So you can calculate this basic number of chargers will be installed in Korea. Please go on the next page. Yeah, I would like to explain something more, the technical part, but you don't have to get any headache to understand this part. I would like to give as simple as I can. The charging station on the charging system, this will be operated as like this figure. First of all, EVCC, the communication modem, will give some first packet as a request to the EVCC. SECC is a charging station modem, and then this modem will respond to the EVCC. That routine is exactly same as from the beginning of the charging and then the end of the charging. So based on that communication, basically charging is to give the power or the voltage and current from the grid side to the PMS and the battery. So the charging station is changed the AC to the DC, and then voltage link will be up to the level of the battery. So voltage link will be synchronized. After doing that, the current will be raised. You can take a look of that graph. Is it right? The next of this figure, that is a very the fresh baked test result I tested yesterday. You can take a look. This voltage is raised up to the the line is blue. The voltage link is up to the more or less the 500 volt and the 400 volt, and then current is up and down, and according to the EV request, and then the SOC is the lamping up to the 100%. So you can guess it. that is quite complicated, but we can categorize something different part, like a communication and then voltage and current. Anyway, if you take any of the fault, communication and voltage and current, or different behavior, charging is failed. So interoperability concept is just based on this figure. Anything could be to happen to make some failure on the charging system. We try to categorize it as an interoperability issue, especially on the not compliant behavior, or it is at a different interpretation, even if we have this the charging station standard. Go on the next page. Yeah, we have lots of the standard, but I don't want to explain that each of the standard at the moment. Just to take a look at how many the standard are they relevant to the charging system and then charging behaviors. There's a quite complicated. That means that any manufacturers, any OEM can make some inconsistent interpretation into their charging system or EV. It's just a feeling from this table. Please go on the next page. Yeah, this is just an example. Sometimes the people try to think the interoperability is only the relate to the communication part, but it's not true. The interoperability, as I told you right before in the previous page, that every behavior for the charging is totally rely on the charging station interoperability. So this is a very good example. During the cable check, the charging system is a go up to the voltage with the rating voltage, and then they means that the charging station will check the insulation between the DC line and then other lines for the safety. So standard, the specified only the voltage and then just right up to the voltage to the rating voltage level, and then go on there, the check, and then finish it. That is done. It's finished for the cable check. And you can take a look, only the very simple the sentences for the cable check specification, but you can take a look of the right table, write this graph. In the real world, implementation is quite different. Sometimes it raises up the very fast, but some other EVSE stay still and then rise up the voltage with some delay. So how gonna do is it is quite critical to make any of their interpretation differences, and then finally they make some interoperability issues. Go on the next page. So in the beginning of this process, all experts from the CharIN expected we will have the more than 300 EV models in the global market, and then more than 3,000 EVSE models in the global market. But at the moment, I guess that is might be the wrong number, because we will have the more than 300 EV models and then more than 3,000 EVSE model in the maybe the 5 years. That means we will have the more combination to make some interoperability issues in the field. You will have many of the cases of the interoperability issues. After that, you can finally get any of some problem like unexpected charging start failure, and then not intended charging stop, and then sporadic the charging stop, and then not unplugging after charging stop. That is just an example for interoperability result. Finally, you feel uncomfortable experience or uncomfortable charging fielding into this market, and then the charging time, this will be longer than we expected, and then you can get some charging failure during the the charging experience, totally that will mitigate something wrong into the market promotion and then market behavior, market perspective. So we will get over this problem and we are going to do something. Please go on to the next page. So firstly, we introduce the interoperability testing. That is a first stage of some activity for interoperability. These might be very simple. We can get together and then test each other. From the 2012 or the 13, the ISO organized this event, and then now the CharIN took over that event for 3 times in the world. In Korea, we have organized 2 times DC Combo Festival. We had a very good successful result. Anyway, that is the limited solution. You can take a look, some video clip. If you click that, there's a link. Please go on the next page. Yeah, as announced of the Jack, in this year, we means and the CharIN and CARI organized CharIN Asia Festival from the 7th and 9th September 2021. The place will be the Ansan branch of the CARI. So if you take a look, or if you have more information about that, please contact Jack or me or the CharIN coordination office. So please be interested in this event, and I'm looking forward to participating from your side. Go on the next page. I try to compare 2 different solutions to mitigate or to get some resolution of the interoperability issues. First thing, as I told you right before, interoperability testing. That will be the simplified one. We get together and then test each other. We will finally get some resolution or the result between 2 different the EV and EVSEs. But as I just give some message, we will have the more EV and EVSEs. That might be the limited solution. It is not feasible for the global growing market. That will be just a event-driven solution. We will find the problem and then reproductive issues from the field into some testing spot, something like that. We will improve some requirement on the standard based on the lesson learned from this interoperability testing. That's all. We need to find out some reasonable and then scalability solution for the testing. So we introduced the conformance testing. We can give some the testing system to EV and EVSE. We can provide the test cases, and then we follow just the processes and then test cases, and then utilize the testing system. We can give and then we can achieve the great level of the interoperability. So from now, I'm going to give just a short introduction as to what we have done in the CharIN Focus Group. Please go on the next page. Okay, yeah, this is just our group. The group name is a focus group, the conformance testing interoperability. We have made some of the testing event. You can see there's a figure like over there. And then we have the 3 different teams. The first team is the development, and the qualification team is led by myself. And then vendor team is led by the Jan Grossman. Please go on the next page. So what do you need for this process? Conformance testing. You can visit for this testing, and then you can apply to your applicant, and into some testing houses, and then you can get some conformance testing services at anywhere and any time. That is a main objective of this process. Before doing that, we need to stable specification, and then we require some validated testing system. Finally, we have to check if the testing houses have a full competence for this testing, and then have this inconsistent interpretation between them. Finally, we can provide fully interpreted or fully interoperable the EV and EVSE in the market. That is the basic step. We categorize the 3 steps for this process. Go on the next page. And then we categorize the 3 different specifications for better understanding of the users and the stakeholders. First thing is the CCS basic that indicated the very simplified the charging system up to the 500 ohms. And that means 400 kilowatt charger will be covered by the CCS basic, but the protocol is the first level of the implementation way. The next is a CCS basic, CCS extended that might be the included from the plug and charge, and then it's smart charging, something like that. Finally, the CCS Advanced includes is automated ACD technology and the wireless power transfer, and then binary power transfer as well. At the moment, we're working on the CCS basic. Firstly, go on the next page. Yeah, to introduce the specification, we categorized some test cases and then developed some test cases. Test case number is 191. So in order to achieve the certificate in this process, every EV and every VSE that have to get some passed verdict from 191 test cases. All their document is having developed into the one name of umbrella document for conformance testing in the CharIN SVN repository. Go on the next page. Yeah, this is a performance check in order to depict how the voltage and current could be fulfilled for 400 kilowatt. So the CharIN tried to develop the one document to depict the basic performance curve, like this, some of the graph. So if you have that document, you can see there's any the performance level or the basic current and voltage to be fulfilled as a EVSE and then EV. Go on the next page. This is a plan. This is very, very important. Yeah, that's based on our plan that we the final pace of this validation CCTS is the testing system validation and testing house assessment will start from now, and then that will be finished within 6 weeks according to our plan. But that is just a plan. Don't believe everything. At the moment, the candidate of the CCTS for CCS basic EVSE DC. This is the testing system for EVSE. The candidate are the Berisco and the Comemso and Keysight. First pilot project of the testing house assessment are the CARI and DECRA. And then after the establishment of the first regular assessment process, we will introduce the first regular assessment where the tube suit, maybe the umlaut. Those of the 7 participants are very, very strong and then active, that expertise, that entities. We have this greatest volunteers to make some this process. Go on the next page. this is just a table to give you some information about the new technology of the CCS. So if this the presentation file that will be shared to your site, please take a look of the new technology in your site. Go on the next page. I always include this link to show you about the detail of how behaviors will be made about the PNC and the ACD and then bidirectional and the wise power transfer. That is just a reference. Go on the next page. Yeah, this is just introduction of the CharIN this year. Yeah, it's a government-funded testing lab and the research institute. So we're working for the standardization and then testing system development, the testing scheme development or the process development. And then I'm the leading of the qualification team in the CharIN. Okay, that's all. Yeah.
Thank you, William. Thanks a lot for this introduction. I have one question that came already from the audience. There is one slide where you mention all the different problems that can occur, interoperability issues, and the question is, when you mentioned not unplugging after charging stop, what does that mean? That you cannot pull out the plug because it's locked?
Yeah.
Okay.
For safety. Yeah.
Okay. So, yeah. Can you explain it a bit more? Yeah.
Yeah. It's based on the CCS requirement. After charging, this voltage between the DC plus and DC minus should be under the 60 volt. But sometimes, sometimes the voltage is slowly get down to the 60 volt. So at the moment, if we realize, okay, this is not safe, and then I just rock this unplugging.
Okay.
So the users cannot plug out.
Okay, good. All right, let's go to your polling question now. Ariane, is that possible? So in 2024, how many models of EV do you expect in your market, excluding the existing one? So 10 new models, 10 to 30 new EVs, 30 to 50 new EVs, or more than 50? That's an interesting question, especially for interoperability issues. It will get out of control with so many new models if nothing happens. So what is the result? We see, wow, in certain regions, more than 50 different models. That's pretty impressive. Any comment from your side, William?
Yeah, that is a very huge number. That we expect a huge number of the EVs will be released within 3 years and 4 years.
Yeah, and there are a lot of newcomers on the market which are not traditionally from the automotive industry. So it will be very interesting to see all these things happening at the same time.
Right.
All right. Thank you, William. We'll get back to other questions later on, and we will go now to the next speaker, to Jan Grossman. Hi, Jan. So Jan is from Vector, and he will introduce you the testing systems that they manufacture. All right. Thanks a lot.
Thank you. Thank you, Jacques. Yes, good afternoon to the Asian people. My name is Jan Grossman. I'm from Germany, from Vector Informatik, one of the vendor who is offering testing equipment for CCS. And yes, I want to introduce the CCTS, so that CharIN CCS test system a little bit more. So next slide, please. Yes, I think you have seen the name CCTS or the abbreviation CCTS a lot of times. So I've written it here. Exactly, it's the name is CCTS, stands for CharIN CCS Test System, and it was established by the vendor team or defined by the vendor team. So the vendor team is a subgroup of the focus group conformance test and interoperability, one of the 5 focus groups of CharIN. And yeah, as you see on the name vendor team, there are all the vendors or some vendors together working in the subgroup. And as you can see on these tasks, what we did or do in this subgroup, I've copied the task from the CharIN website of the whole focus group. So the gray out ones are not the tasks of the vendor team, but the last 2. So the main task of the vendor team is to define a vendor neutral and CharIN compliant test system, the CCTS, which is suitable for interoperability and conformance testing. And of course, our task is not only definition of such a test system, also maintenance of the CCTS specification. So this consists of hardware, software, and also test cases. So this is the background, which team or who did the specification or the establishing of the CCTS. So next slide, please. Yes, I think Woyun has shown a similar picture as you can see on the right side of my slides, but I think this is very important to understand why we need a test system, a CCTS. That's why I have it also on my slides here, because what we do on our test evals currently, CharIN has announced them for Europe and Asia and the US. I think these are important events. They still important, but I think that the right approach, as we have seen on the poll question before, that the market is growing very fast. So the right approach for the future is not to do the manual testing, so testing each vehicle against each charging station. That could be an addition, but the right approach is to do the automated testing, as you see on the right picture on the bottom, testing against the CCTS. And the advantage is for automatic testing, you test not only an implementation versus another implementation like you do in the manual testing. You have with a CCTS, with a test system, you have also the possibility to have error cases. That means you have not only a good case run, but you can also produce errors and see how the EV or EVSE behaves on this certain errors. And I think this is, or the vendor team and whole CharIN thinks this is scalable for a growing market to handle the big amount of EV and EVSEs we expect in the future. So next slide, please. Yeah, so on this slide, I've prepared some facts, a little bit background information about the CCTS. So when we started with the vendor team some years ago, the CCTS was known as GTD. So we started Golden Test Device, and it was the name from a founded project in Germany. It's called SLAM. And we took over all the existing information and data and the output of this founded project, and we developed it further to the CCTS we have right now. So we also changed the name from GTD to CCTS because it's very important, because if you see the name Golden Test Device, it says you have only one device which is really golden. It's somewhere in the world or on each continent, one of this test system, and it's a golden one you can test against, but this is not the case. So if you see my second point on the general column, this CCTS should be available from different vendors based on a particular CharIN specification. So it's not a golden device, a unique device. It's a test system you can get from different vendors, from each vendor who is capable to fulfill this CharIN specification. And it's important that, of course, it will support the CharIN CCS step model, which also Woyun had shown already. I have also in my later slides some more information about the CCS model. Of course, we have to respect all relevant CCS standards, otherwise you can't use it as a CCS test system. We have some complex market requirements, also some local regulations, some other compliance issues we have to take care about. And this is also important. This CCTS should enable the product certification of EV and EVSE, which we have also seen in Woyun's slide. And also important to know, it's the design, the architecture of the CCTS should be modular and scalable. That means we have taken care within the vendor team when we establish the specification that it covers only the minimum requirements. That says if you need a bigger test system, it's no problem, you can use it, but your test system to execute these test cases for product certification should fulfill some minimum requirements we have defined here. And then it's also important that the CCTS specifies not overall big test system. It specifies single parts which you can use. So for example, if you test only controller, it's you can only use the communication part of this test system of our specification. If you have a testing complete EV and EVSE, you have a complete test system including power part. And of course, if you start with communication testing, you can expand it to cover all parts of SUTs. And also for the power transfer part, which is normally the most expensive and biggest part of a test system, it's also scalable according to the HPC power classes. So they are also defined by CharIN. And if you say you have a vehicle which is up to 50 kilowatts of charging, then of course your test system don't need provide a power part which is suitable of 500 kilowatts. That's too much. So you can adapt your test system also to the power class of your system under test. So next slide, please. Yeah, on this slide you see the architecture of such a test system. We have if you can see on the right side, we have a public part. It's in the blue area where we have all the documents and test specifications we have considered. We have a CharIN function list which defines all the functions of the CCTS, and of course it's important if you want to compare the results of different vendors of different test systems, you need a unified report format. And the vendor specific part, it's the green part inside this picture. It's dependent on each vendor how this part look like. So every vendor, every test system has a little bit of different testing architecture, but as it's inside the test the CCTS specification, then it's okay. But this is really a vendor specific part. But it should contain all the mentioned parts here. Of course, for each test system, you should have a test execution part. On the left side, you see the reporting part. You should be able to report all the verdicts, the pass or failed verdicts. Then you have a low-level communication part, high-level communication part, a power transfer part. You have a security part for ISO 15118 plug and charge, and you need some advanced fault insertion especially for the testing the EVSEs. And as I said on my previous slide, this is an overall architecture overview. But if you say you only want to test your communication controller, then you need, for example, you don't need 0.3 or 0.5. You need no power transfer or advanced fault insertion, for example. So next slide, please. Yeah, this is the step model Woyun has shown already. As he said, we have CCS basic, extended, and advanced. And what we did from the vendor team, we took care that all these step models, these steps, the basic, extended, and advanced, will also be fulfilled or can be tested with the CCTS. So if you go to the next slide, please. yeah, what you can see on this slide is on the left side, again, on the green area, the vendor-specific part of a test system means low-level, high-level communication, security, power transfer, advanced fault insertion. On the right side, this picture, you see a table where you can see how it is matched to the different steps of the step model. So the first column in this picture, in this table on the right side, you see the three steps: CCS Basic, Extended, and Advanced. And then you see the different configuration which can be possible. So the easiest way is charging without high-level communication, only PWM based on the AC. Then with AC voltage, then of course you need, your test system only needs a low-level communication part to stimulate and measure the PWM signal in the proximity pin. And of course you need for the power transfer an AC source or sink. So that's how you see this crosses only in 0.5 low-level communication and the AC part of power transfer. So if you only want, for example, to test this, then you need only a CCTS which is equipped with these parts are mentioned here. And if you go a little bit down, for example, the CCS Extended, which only also supports plug and charge communication. So if you take, for example, the configuration, the plug and charge with power transfer, which means ISO 15118 plug and charge with power transfer, then you need of course lots of more parts in your CCTS. Like, of course, what you always need, the PWM communication in the proximity pin. Then you need a home plug green PHY connection from the high-level communication. You need AC/DC power transfer. You need the 0.4, the security for TLS encryption. And if you want to test the power part, you always need advanced fault insertion, which we have divided in two parts, in the basic and safety lab. So the basic ones are fault insertions you can do everywhere in your office, in your normal lab. And these ones which are signed with safety lab, these are very special tests. For example, making a short circuit under full load. So that means during the charging under full load, you make a short circuit, and the EVSE, for example, should detect this and shut down. But if something goes wrong, you have high power, high currents, high voltages. This is so this tests, this particular one, for example, I mentioned, you can also only execute in the safety lab. That's why we have divided the fault insertion use cases in the basic, in the safety lab. And the last part is CCS Advanced. We have it's grayed out here because it's not current in our scope. Our current scope is to support the basic and extended charging, what we have currently on the market. So the CCS Advanced, you see it's BPT, VPT, WPT, and ACD. These are new technologies which are used in the next generation in the ISO 15118-20. But of course, in the future, we will also follow this -20 specifications that the CCTS will also support these special technologies. But in this case, especially for the wireless power transfer, we need to introduce an additional high-level communication. It's the 802.1n. It's Wi-Fi communication. So if you go down to the CCS Advanced, you see the crosses on the high-level communication for the Wi-Fi communication. So this is possible, as I said at the beginning. It's a scalable design of the CCTS, so it's no problem to add also the Wi-Fi communication later to support the CCS Advanced step. So this was my last slide for today, and I'm waiting for your interest and questions. Thank you too.
Thank you. So Jan, I have one one question. If you buy such a CCTS system, I suppose you get answers out of this machine, but it's not like a green light or a red light. It's going to be, you will need to be able to interpret those answers. So buying a machine, I think, is not enough. You need also maybe training, or you need specific knowledge to be able to use these CCTS systems. Can you expand a little bit on that point?
Yes, you're right. Basically, the result, if you have a test run of, I think Boyun has shown it on the slides, these are several hundred test cases, and the CCTS test system is capable to doing this automatically. So it takes some time, but you can run, for example, 200 test cases in automatically, and then you get a test result. And the easiest way is everything is passed, then you get a green line. But normally this is not the case. So if you have in your detailed test report also some test cases which the verdict is failed, which is marked red, yeah, of course, then you have to do some analysis. And I think for this, it's detailed knowledge is possible about the standards, not only the communication standard, but also about the test specification. And I think this is the main knowledge that our customers or the users should have, because I think setting up a test system and start a play button to run automatically tests, this is what you do. You have to do once. It's also some work, but the main work I see is having the knowledge, the expertise to interpret this test report.
Right. Yeah, that's also very, very important. So now we'll be having a poll about who would be interested to invest in such kind of equipment. So I can imagine EV manufacturers, EVSEs manufacturers will want to have such an equipment on hand, maybe to do some basic tests before they go to certification. So we are keen to know, in the next 8 months, do you think your company will be investing in this type of equipment? And the results are, oh, no, not too bad. Yeah. What do you think about it, these numbers? That's good for sales.
Yeah, good for sales. But as I mentioned in my previous slide, it was this was an important thing for the vendors in the vendor team to only specify the minimum requirements. That means I think a lot of systems which are already owned by our customers, you can again reuse or update with a small effort to work as CCTS. So I don't expect that most of the customers which have already a test system don't have to buy another one, perhaps update the existing one. That's what we have taken care of. But I think if you've seen on my slides, manually testing, that means testing each vehicle against each charging station, you cannot handle this. So it's important to have a test system. I think you can't handle this without a test system.
Right. Okay. Good. Thank you, Jan. We'll get back.
You're welcome. Thank you.
Thank you. So now we have our next speaker. This is Albi Kospiri from TÜV Süd, who will be talking a little bit more in detail about the practical things of doing those tests. And I think he will all be touching a little bit of V2G, or maybe more than that.
Thank you very much, Jacques, for your kind words and presentation. Yes, I would like to go through with you today actually on the implementation of the grid codes, requirements for testing, with a focus on the vehicle to grid and some practical examples on the ISO 15118. This might be some future topics actually, but I would like to bring here our experience with the grid codes and make good use of it in the CharIN environment for the vehicle to grid application. So next slide, please. let me spend here some words about TÜV Süd. TÜV, it's a one-stop independent technical solution provider with an experience more than 150 years in safety security business, with over 25,000 employees in more than 1,000 locations around the world. Next slide, please. And in our department, we follow all the topics around e-mobility and smart grid, from communication protocol testing to grid codes, from functional safety to IT security. Next slide, please. But we want to talk today about vehicle to grids and grid codes implementation and testing. So let's begin with some key points on vehicle to grid. I think we can safely say that the benefits of the vehicle to grid implementations, such as voltage and frequency regulation, load management, or a smooth integration of renewables, outweigh the challenges that are in front of us. For example, the battery degradation. Next slide, please. And its potential, actually, it's enormous, with an estimated battery capacity of electric vehicles in 2050 at around about 2.4 terawatt hours, and with, of course, we have seen these years an electrical vehicle number is really increasing strongly. So these are our main topics of today's presentation. Let me spend here, next slide, please. Let's see here what do we mean with grid codes, for those who do not know these terms. All the generating devices connected to the grid have to comply with these technical rules, which are called grid codes, in order to guarantee a stable operation of the electrical grid. And with these topics now on our view, let's have a look on the normative landscape from both grid code side and the vehicle to grid side. Next slide, please. Let's begin then, next slide again. Let's begin then with the normative landscape of the grid codes. I've brought here some examples from Germany, which specify the grid codes in the low and medium voltage levels. Of course, there are similar requirements in other countries as well, and they differ with some small configurations and parameters, actually. Next slide, please. From the other side, the normative landscape of the vehicle to grid environment is well developed also in the CharIN area. We are speaking here about the ISO 15118-20, which is at the moment at a draft version and is going to be finalized hopefully this year. It includes a bidirectional power transfer function and a lot of grid codes related parameters. Actually, I've brought some examples here on the right side of the slide, and they show very well what can be handled with this standard. So what do I mean? All these grid code rules are well managed through the standards, but let's have a more thorough look on the grid code rules. What are those? If we can go to the next slide, please. Let me show you some functions of the grid code specifications. For example, this fold right through that you see in the upper left part of the slide. Here is the ability of a generator, in this case, the combination of the EV and the VSE, the ability to stay connected during a short period of low network voltage on the grid. Another example can be here the active power control. So it's the control of the frequency of the network through an active power of the EV and EVSE. This is going to be actually primary role of the vehicle to grid in the future. Next slide, please. So we're going to see now some testing requirements for Mode 3 and Mode 4 charging stations, so in AC and DC. Let's begin, next slide please, with the DC charging. We have to have in focus here that the power converter is located, let's say, off board. So it's always a stationary charging device. And this is why we have to consider the system under test here only the EVSE side. It means that the grid code parameters are programmed into the controller of the EVSE, and from there it has to be managed the power flow from and into the grid. Next slide, please. I've brought here some examples of the implementation of this testing, which is coming from our experience in the grid code testing. And on the right side of the slide, you see the challenges and what we see that we have to overcome during our vehicle to grid implementation. Without entering in too much of detail, let me put here, for example, on the second row, you see these low voltage or high voltage ride-throughs, and the EVSE has to withstand these low voltage faults, for example, so it has to stay connected even though the voltage of the network is quite low. In this scenario, we will see, for example, some challenges. The electric vehicle has to have a buffering of internal energy during these dips, and the maintenance of the communication between the vehicle and the EVSE might be at risk. Next slide, please. On the other hand, in AC charging, the power converter that manages the power flow is located on board, so inside the EV. And in this case, the charging station has to communicate the EV the correct parameters on how to feed back energy into the grid. This is why here we see both the EV and the EVSE actually as the system under test. The risk in these ecosystems is that we can easily slide to a proprietary solution in the information exchange between these two actors, and of course this might harm the future development of the system itself. So let's have a look now on the next slide at two different information exchanges between these actors. The first one is the option that all the grid code guidelines might be implemented in the vehicle itself, and once the vehicle is connected to the charging station, the electric vehicle knows then which parameter are needed from it. The point here, maybe the problem here is seen on the next slide, that the vehicle manufacturer must implement inside all the test cases, and this is quite a hard job actually. The option number two, we see on the next slide, it's the other way around. So the EVSE communicates only the needed parameters to the vehicle in order to say and to profile a discharging way so that the EV does not violate any grid code rules, you know. So yes, this is a quite more handleable approach, but not yet fully implemented on the standard. So till now, on the next slide, we see that for the standard, it has been on a common ground. The option 2 is being preferred more, actually. So then let's have now a quick look at the structured information that we have on the ISO 15118-20, how the information is structured, and where how can we use it better for testing. Actually, we see here two data types. The first one on your right, it's a charging parameter discovery, a request for bidirectional power transfer in AC. Of course, yeah, here a lot of words, but at the end of the day, what I want to underline here is that a lot of parameters are already implemented in the standard, and this helps a lot the implementation of this grid code testing. Another example on your left is the ability of the vehicle and the charging station to continuously communicate in a loop and to exchange information on how to set point on the power level in the network. So both of these examples bring us to the next challenge that, as the panelists mentioned before, this is not foreseen at the moment in the CCS basics, but it will be implemented, of course, in the next steps, and moreover on the Ccs Advanced implementation. It means that from now on we have also to generate some test cases in the CharIN environment that bring this grid code implementation stuff also together with the vehicle to grid. And from the other side, we see another challenge here in the CharIN environment, but not only. We need to push a lot on the DSO level, so the distribution system operators to include vehicle to grid into their grid codes. As we see on the next slide, this is an example in Australia. They have included in the grid codes AS477 on the devices to be covered by the standard. They have included electric vehicles and electric vehicle supply equipment. So they are seen now as the generators and have to withstand all these grid code rules that we have seen above. So by ramping up, actually, if we have here only 3 takeaways from this presentation, which is showing some future topics, but nonetheless not less important, are these following ones. So a test procedure has to be developed for the vehicle to grid implementation with a focus on the grid codes experience, and in order to improve the implementation and to improve the integration of the vehicles to the grid. We need at all costs actually avoid proprietary solutions in the communication and in the data exchange and the hardware also on these 2 actors, so the EV and the EVSE. And at the end of the day, as I mentioned earlier, the vehicle to grid and the vehicle to X, actually home or load or what it might be, has to be recognized as a generator and has to attain the grid code rules. This helps a lot also with the interoperability between different actors in the game, with grid codes from Germany or Australia or wheresoever. And with this, I'd like to close my presentation and quite open to all your questions. Thank you.
Okay, thank you, Ali. Thanks. It went into the direction of V2G, and I like this very much because V2G is really something that will be very important in the e-mobility ecosystem.
Correct. Correct.
Yeah, you mentioned several times about avoiding proprietary solutions between the EV and the EVSE communication. Where to start? We already have several members who are grid operators. Where does the pressure need to go to? Who should we pressure?
Correct. Yes, you are right. I mean, in order to avoid these bottlenecks, actually, and this is quite a bottleneck with all these actors in the game. We have seen also before that a lot of new models are going to be approaching the market in the near future. Maybe the first step to think it about is the standardization. So if we work more closely on the standardization and on the understanding of the common rules, and if we diffuse these common rules and have the same understanding from all the actors, then I do believe that we are really at a good starting point. Yeah.
Okay. You mentioned mode 4 and mode 3. So this issue about proprietary solution is only happening in mode 3. AC.
It is more underlined actually in mode 3. Yes, you are right, but also in mode 4, we do not need so much communication with the vehicle to grid perspective. I mean, so the exchange of the information, of the energetic information between the electric vehicle and the charging station, but it is more pronounced, yes, where we need this information, where is in the mode 3, in the AC, correct?
Okay, good.
Yeah.
All right, so let's go to a poll. The poll is not really about V2G. It's more a question towards the audience about would you use the services of an accredited third party like a TÜV house, a TÜV Süd, like a testing house like TÜV Süd, when you would like to launch your product just before it? How do you perceive this service? Important to take out your final problems because you want to have accreditation so it will improve sales, because you want to comply with your customers' requirements, or there is no need, you really rely on all the in-house testing yourself. So what, in your opinion, is the most important issue where you would say we need to accredit? We need to go to a testing house to test the things. Okay. So
yeah. So I mean, yeah, really interesting results. What's important at this very first stage of the implementation is, of course, to rule out a lot of initial problems. So a third-party accreditation, yeah, we can improve the sales, might be, but it's also important in this not yet fully regulated environment that the customer might need an requirement actually to be tested from independent houses. So these are in lines actually with what we expect from the market.
Okay.
Correct?
Okay. Yeah. Good. All right. So I think we can go to a panel discussion with all the speakers. And I wanted to check, is there any questions that came in from the audience? Please ask questions. These are the experts sitting here. While you are all thinking about questions, let me then come up with a question. And this is this is really a common question. Suppose I come with my equipment, with my EVSE. I test my EVSE and I will get a certification. How long is this certification valid? Is as long as you produce the same product, it's valid, or you would say after 1 year you need to come again to do a certification, or how does it work? Oyun?
Yes, that is a very important part to be discussed in the focus group. We have been discussing these issues, this topic with more or less 6 months. The current status of our certification system, basically any software and then any hardware, the update, the certificate should be reissued. That means the certificate is valid forever, but any change makes them another certificate.
Okay. Yeah. So the slightest component that changes from different make or updated make might affect the certificate.
And then based on there's some opinion from the manufacturer side, is what part is critical to update and change their implementation, and then the what part. So for example, is a minor revision of the software or some not critical part of the hardware change. We are going to categorize them into the critical part and the not critical part, and then within the critical parts, we will give some process to reissue the product based on the requirement of the QAP, quality assurance plan in CharIN.
Okay. Yeah.
So, Albi, do you have any opinion? Actually, I have.
Yes, you're right. From our experience, actually, of course, the certificate itself is connected with a firmware version, a hardware version, and then it's valid as long as they are in the market. Yes, a lot of points come up here for interoperability stuff. A firmware version of an EVSE might not work very well with the newest release of 15.11.8 and so on. So yes, the basic components might be valid, not strictly related with a firmware version, but of course, gap analysis has to be done also in order to evaluate whether the certificate is valid for a longer time. I mean, yeah.
Albi, you touched about V2G, although it's not yet covered in the Ccs Advanced. I mean, it's still under development. This is very linked to regional codes, I assume. They might be even different from country to country. So how are you going to do this certification? Is this going to be region specific? Is CCS Basic going to be region specific, or is it only CCS Advanced going to be region specific? Oh.
This is really a very good question, actually. Let's begin by talking for the vehicle to grid implementation. And from our experience, at least in the grid code environment, so on these rules on how to connect the generators into the network, we do specific tests for all countries. Italy, Germany, Australia, North America specifically, and so on, you know. So you have to certify that in every region they comply with these rules. Now, whether this is going to be the case also in the CharIN environment and in the vehicle to grid test and certification, this has to be seen. It might be an option, of course. It might be an option, of course. And for example, the grid codes and the vehicle implementation between Germany and Italy do not change too much. We have
Right,
done a gap
yeah.
analysis, and only some parameters have changed. So we can, for example, test only those parameters, and the rest is valid.
Yeah, okay. Jan, from your side, does that mean you will have to develop several different CCTS systems, or will?
So as I, yeah, please.
Yeah.
So, no, I think as I have tried to make clear on my slides, we have one CCTS, but this CCTS can have different parts depending on
Right.
what you want to test. And what also was very important, or is very important for the vendor team, that is this CCTS is future proof. That means especially for the upcoming -20, the bidirectional power transfer and inductive charging. Of course,
Yeah.
we can't handle with the existing CCTS, but we take care about the system design of the CCTS, that it's easy, that is possible to update also such a system, that you don't need to buy another system for if you want to handle, for in example, inductive charging, but in this case that you can add an additional Wi-Fi interface, for example, because we all know it's a big invest for companies to buy a test system, which you not want to do every 1 or 2 years. So yeah, I think it's important to keep them updatable and flexible for all parts we want to test.
Yeah. Now a question to all of you who have been doing extensive testing. What are always the main problems you see coming up with an EVSE manufacturer, for example? And what are the main problems you always see coming up with the EV manufacturer? Are these always the same problems, or are they slowly disappearing over time? Woo-Yun, you may, for the Korean market, maybe?
Yeah, that is a very good question, and then very difficult to answer, because the life cycle of the charger might be 7 years, then 8 years, 9 years. That means if we start some improvement of the charger's quality, the result will be gathered or will be achieved with the 8 years and 9 years and 7 years, something like that. And then, so do we need to start something more? So in order to answer your question, if we can remove any of the interoperability issues with this conformance testing, yeah, that might be the yes. And then our target is a 99% to 98% of the interoperability issues will be resolved with this process, I believe. But if you take a look on the short time result, it doesn't seem to be like that, because the progress will be very slow. We have to change the free or the legacy infrastructure of the charging. It should be improved. That means we start within a short time, and then we need to get in rush to start to providing this certification system, and then provide the conformance testing. And then now we are going to figure out what problem will be happened in the field. So the problem might be totally different from the manufacturer to manufacturer. And then in the EV side, the basic pattern is slightly or totally different between the EV and EVSE. So we have to categorize something, those of their issues into the big topics, and then we are going to figure out and then make some solution as a test cases and the full field test case into against the EV and EVSE, and then we will make some the better infrastructure of charging from now to maybe next 8 years and 9 years. This is just my opinion.
Jan or Albi, any further comments?
Yeah, I would not point out the difference of the problem between EV and EVSE manufacturers. I think I would more point out the common thing, which we also should achieve in CharIN, is to provide a whole ecosystem based on the process from Wuyon, the Ccts from the vendors, and also the suitable test cases, and do a continuous development of this process, which one part we have seen today is the certification with test houses, but I think also the test wells you have mentioned at the beginning, Jacques, they are also so important. Perhaps you can reduce them. I think this is the important way for the next 2 years, independent from EV and EVSE side, to have a good approach how to ensure the interoperability with test cases, test houses, the whole ecosystem. I think, and to make it, I think, not mandatory for everything, but to give everything the possibility to do the same testing. So it makes no sense if on the EV side they do a lot of testing in the vehicles. On the other side, on the EVSE side, there is not done the same level of testing. So I think this will only work in the interoperability if both sides have the same tools, have the same mindset or the same quality approach. Then I think only then it will work to get a good interoperability.
Here is a question from from the audience, and there are maybe Albi, you can answer this because this is more related to the different testing houses that you have worldwide. Will there be, or are there any countries, regions that will make CCTS testing certification mandatory?
Oh, this
Do you
is
this in the future, or
a big question. At least at the very state of the art, no CCTS testing certification is mandatory worldwide. But let's take it on a more specific level. For example, the 15.11.8. If these rules are going to be included in the standards or in any technical documentation, then they have to be tested. So it means that it becomes automatic mandatorily. Let me connect it also to some questions I see here from the vehicle to grid environment, whether in Europe, for example, is there any specific reason that we have different vehicle to grid or grid codes specification in Europe? It is so the Italians want to do it their way, and the Germans also, Spanish and France, etc., etc. So it is so. It exists. At European level, a standard, the EN 54549, which includes all the most important topics. So it is doable also in the European level. And yes, in the mode 3, EVSE, we see as mandatory the implementation of the grid codes. It means that the standard, so the ISO 15118, gives us the opportunity to configure these parameters into the EVSE, and once it is done, they're in forever. Actually, yeah.
Okay. Jan and Wuyon, I'd maybe come to both of you. It's about a CCTS system. So we have different manufacturers. We're all making fantastic CCTS systems. And when they discover an error, they should give the same outcome. And I understand from testing that sometimes it's not very easy to define where is a problem coming from. So to make sure that all the testing systems, so if I buy testing system A, you have testing system B, and we are testing an EV or an EVSE, the test result should be the same. So who is in charge of calibrating those systems so that all the CCTS systems give the same results?
Okay, let me explain the first. After that, Jan maybe give the better impression or get better opinion. In this process, we have three different buffers or the three different level of the checking about the test result. First thing, the calibration will be fulfilled by vendor before providing then their product, the CCTS, to the testing house or the manufacturer side. And then the testing house have to check if this testing system will be the valid or the validated or correctly operated under their own qualification system. And then finally, the CharIN will check assess the competence of the different testing houses result. And so we try to compare 2 times. Firstly, CCTS validation. To compare every verdict of the every test cases by expert, and then finally the CCTS vendors can get the recognized or the validated testing system mark from the CharIN after the passing have the consistent verdict with the other testing systems. We compare testing systems and we will we will try to check this consistent verdict. Correct or not is a different concept. After that, we try to check again based on the test result provided by the testing houses. So we try to get some different steps. The first thing is CCTS validation to compare. The other one is a testing house assessment to compare again. That is our process. And then Jan, do you have a more and better insight?
I don't have better insight. I think you have to see not only the CCTS. So I think what you mentioned, and I know it. It's since months we do some live events during the COVID-19, also virtual events. So every vendor is testing at home and providing his comparable test results. I think it's a very complex issue because you don't only have to guarantee as vendor that the CCTS will fulfill the specifications. You can do this with calibration, but this is only the hardware part. So this is, I don't want to say the easiest thing, but I think the more complex is the combination with the test cases, because I think there you have more variety. I think for hardware, it's easy. If you say you have to output 15 volts, for example, or 600 volts, you can calibrate this, you can measure this. It's very easy to verify. But to that your test cases are working exactly, I think this is a big effort, because of course you have a test specification. Based on this test specification, you implement your test cases, but there's also some space for interpretation of the test cases. And I think the most important thing why we have spent so much time is to keep or to have an overview about the whole system, including test cases and the CCTS, because the CCTS, as I said, is only one part of this whole system, which needs to verify it. And before you can verify or make the assessment of testing houses, you have to make the assessment of the CCTS, that it's suitable to execute these test cases and gives the right results.
Okay, thank you. I think we are now close to the end of the event, so I have many more questions. Unfortunately, time is running out. I would like to thank all of you for joining us for this event, because this is something I always am very interested in, because it's a question that comes back all the time. Where can I test? How can I test? How long does it take to test? So having you here and talking about that is really, really, really good. And before I forget, to all the audience, please go to our freshly minted website. It's super cool. It's CharIN.global. Really go and have a look. It's really a completely new environment, and you will find a lot of new information on that website. And once again, there are 3 festivals that will be taking place. One in April in Europe, another one in September at Woo Yoon's facility in Cary, and then a last one at Lucid in United States in November. So if you have anything to test, bring it over there, and you'll discover how good your product is or how much work is still needed to make it commercially available. So Albie, thank you very much. Woo Yoon, thank you very much. And Jan, thank you very much for joining us. I really enjoy it. Thank you.
Thank you.
See you.
Bye.
Thank
Bye-bye.
you. Bye-bye. Bye.
Bye.